9618 P31 May June 21. P31. Real numbers are stored in a computer system using floating point representation with 10 bits for mantissa and 6 bits for exponent. 2's complement form for the mantissa and the exponent are these. Okay, so minus 7.25. So we will not be taking minus 7.25, rather we will be taking it as plus 7.25. So 7 will be 1, 2, 4, 0.25 will be 0.5, 0.25. So this is basically your fixed point notation. Okay, now we will move the point all the way towards the left. So this will become 0.11101, and we have moved point 3 times. So that is 2 to power 3. Two to power 3. Now we will write it in floating point form 0, 1, 1, 1, 0, 1, and 1, 2, 4. So this is floating point. Now we have to fill it. We will fill it from left to right and this one from right to left. But this was actually negative. So this is plus 7.25. So in order to make it minus 7.25, you will keep the exponent same. And in the mantissa from the right side to the first one, we will keep it same and inverse the rest. Okay. So what we will do whenever the question is in minus, it is negative, we will take the positive of it and we will solve it. Once we get the answer, we will keep the mantissa same. Sorry, we will keep the exponent same, and in the mantissa from the right side to the first one, we will keep it all same and then toggle the rest. We will make all the zeros ones and one zeros after the first one. Until the first one from the right, we will keep it same. So this is negative 7.25. So now we will fill it from left to right. 1, 0, 0, 0, 1, 1, and whatever the bits are left, we will fill 0 in it. And exponent from right to left, 1, 1, 0, 0, 0, 0. So this is your answer. Okay. Yes, this is correct. Okay, now part B. Calculate the ternary value of the given floating point number show your working. So this is negative number. How do we know that this is negative? If we have got 1 in the most significant bit in the mantissa, it means it is negative number. So 1, 0, 1, 1, 0, 0, 0, 1, 1, 1, and then we have exponent 0, 1, 1, 1. So this is negative number. First, let's make it positive by keeping the exponent same to the first one in the mantissa same and toggling the rest. Now convert it to fixed point 0.100111100 into 2 to power 7. Now resolve this 1, 2, 3, 4, 5, 6, 7. So point will go towards the right. Why towards the right? Because your exponent is positive. When the exponent is positive, point travels right. For creation, we go to the left, but when we try to solve it, we go to the right. So 1, 2, 3, 4, 5, 6, 7. So this will become 1001110.01. Now this is your fixed point. So let's solve it now. 0.01 is basically 0.25, and this is 1, 2, 4, 8, 16, 32, 64. 64. This is minus 78.25. Why minus? Because the original number was negative. So we made it positive and we solved it. Once it is solved, then we put this negative mark on it. 2 की पावर 7 कैसे हुई? 2 की पावर 7 ऐसे हुई कि ये एक्सपोनेंट जो है, this is 7. 1, 2, 4. 4 plus 2 plus 1 is equal to 7. All right, so let's move forward. The given binary floating point number is not normalized. Normalize the floating point number. Now we have to first check that which two numbers are different. These two are different. So whatever in between will be taken out. So this will become what? 0, 1, 1, 1, and whatever left on the right will be filled with zeros. Now, how many bits we have removed? We have removed 1, 2, 3, 4, 5, 6. So this number is basically 1, 1, 1, 0, 0, 1. So 1, 2, 4, 8, 16, minus 32. So this is minus 32 plus 7. So this one will be 1, 0, 0, 1, 1, 0. 25. All right. So this is negative 25. So minus, this will become minus 25. Minus 25. Minus 25 minus 1, 2, 3, 4, 5, 6. So minus 25 minus 6 will become minus minus plus minus 32. Now minus 25 plus 6. Minus 25 minus 6. Minus 31. Minus 31. So this will be 31 plus. So this will be, this is minus 31. Okay. So this is your answer. So what basically happened that the mantissa is actually positive. The exponent is actually negative. So what we do, we take out all the zeros. How do we know that this is non-normalized? First two bits are same. So we take out all the ones or the zeros between the first bit and the first different bit. And then we count how many are these? 1, 2, 3, 4, 5, 6. And then we subtract the count of all the digits that we have taken out from the exponent. In this case, exponent itself is negative. So this is minus 25. So minus 25 minus 6 become minus 31. So this is minus 31. All right, so this is your answer. 0, 111, all zeros in mantissa, and 1, 0, 0, 0, 0, 1 in exponent. The denary number 513 cannot be stored accurately as a normalized floating point number in this computer system. Explain the reason for it. So 513 requires, we have got only 10 bits for mantissa. Okay, we have got only 10 bits for Mantissa. For 513, we need, I think, 11 bits. All right, how do we know that for 513 we need 11 bits? So check it out. 1, 2, 4, 8, 16, 32, 64, 128, 256, 512. So for 513, we have to have this 1024. Okay, so this 513 is not 513, this is plus 513. So we have to have another bit. So how many bits do we need? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We need 11 bits to accommodate plus 513, and we have got 10 bits. So explain, we need 11 bits to store positive 513, and we only have 10 bits available in Mantissa. So maximum positive number that you can save is when you put all ones over here. Okay, in 10 bits. All right. So if we try to accommodate plus 513 as 10 bits can only accommodate up to plus 511. How do I know that plus 51? Anything that you add before this 512 will be 511. Okay. An overflow will occur. An overflow will occur. If you try to put data for 11 bits in 10 bits space, obviously on the left, the bit will be dropped, or from the right, the bit will be dropped. Could the exponent also have been expressed as, yes, why not? Definitely, but this one is 1, 2, 4, 8, 16. This is 31. So why would you move Hania 31 times the point? You don't need it since this is plus 513.0. So it means that exponent is all zeros. This is exponent. This is Mantissa. You don't have anything. All right. So this is complete integer sort number. It is real. That is why it is 0.0. If it is 0.0, we don't need to put anything in Mantissa. I mean exponent, sorry. Describe an alteration to the way floating point numbers are stored to enable this number to be stored accurately using same total number of bits. We need to increase bits in Mantissa. Consequently, bit in exponent will be decreased. What does that mean? You have 10 bits here and 6-bit there. 6-bit. We will move this slider a little towards right side. So that will give us one more space. So this will be 5 and this will be 11. Keeping overall number of the bits same to 16. This can be done. Okay. You was asking for part C. No, no, you cannot, because the original number is negative, and when you subtract from negative number, you have a negative number. What you have shown to me, Hania, that was positive. Question number 2, describe the purpose of user-defined data type. It is uh, to create a type out of existing types. When uh, used language does not have this uniquely required type by default. Question is, why do we need user? What is the purpose that we need user defined types? All right. It is to create a type out of existing types when used language does not have this uniquely required type by default. So we need to create. Okay. Define using pseudocode the following enumeration data types. School day, to hold data about the day the students are usually in school. So this will be type school day is equal to Monday, Tuesday, Wednesday, Thursday, and Friday. So this is your type. Weekend, to hold data about the days that are not in school type. So, all right. So type weekend is equal to Saturday and Sunday. All right. So this is our user defined type for enumeration, as in the values of the list of the values. Define using pseudocode the composite data. The composite data type is the type that is made up of other data types. Using pseudocode the composite data type club meet. This will hold data about the club members that include first name and last name. All right. Type club meet. Declare first name as a string. Declare last name as a string. One, the 2 days that are the 2 days they attend. Okay, one on a school day, one not on a school day. It means that they are talking about a school day and weekend. All right. Declare school day as school day. And declare weekend as weekend. All right, end time. So this is what they wanted. Now, question number 3. Draw one line to connect each operating system term to the most appropriate description. Okay. Using secondary storage to simulate additional main memory. This is virtual memory. Managing the processes running on the CPU. This is scheduling. Managing the execution of many programs that appear to run at the same time. This is multitasking. Locating non-contiguous blocks of data and relocating them. This is called locating. This is basically defragmentation. We don't need this here. I don't have any term that says that it is defragmentation. Transferring control to another routine when service is required. So this is basically interrupt handling. Reading, writing same size blocks of data to and from secondary storage when required. So this is paging. So it means that this defragmentation is not there. Okay. Explain how an interpreter executes a program without producing a complete translated version of it. Interpreter reads and scans source code one line at a time. At a time, checks that line statement for any possible errors when error occurs. It stops and report it. Okay. If code is correct, if code line is correct, it executes it. It does the same for every line of code every time the program is executed. Every time the program is executed. So that's it. Question number 4. Explain why reverse polish notation is used to carry out the evaluation of an expression. It is reverse polish notation is an unambiguous method of solution. That is, it does not have any BODMAS related complication. All right. It simply reads from left to right and solves equation without following precedence rules. Okay, so it just goes through the statement from left to right and solves it. Identify with reason a data structure that could be used to evaluate an expression in RPN. Identify the reason, a data structure that could identify with reason, a data structure. We use stack data structure. We use stack data structure so that all operands are pushed in order of appearance and taken out no, taken out is not the right verb, and popped when an operator occurs. Okay. Write the infix expression in reverse Polish notation. So we have got two operators. See, we have BODMAS. Okay. So division, multiplication, and addition, we can follow this, or what you can do, you just start a b minus. You see, this is a b, then we have what, a c, they are being multiplied and then divided by 7. Okay, so you may be like AB minus AC plus asterisk 7 and then divide. Okay, so we will go all the way towards the end, then left, right, root, then left, right, root, then right, and then root. We can solve it this way. Write reverse Polish notation expression as infix expression. I hope that you remember that if we write a plus b, this is infix. If we write ab plus, this is postfix, which we call RPN. And then if I write plus ab, this is prefix. So they are calling for infix notation. So a divided by b, all right, sorry. Let's start using a pushed, b pushed. Then we have divide. So divide, this becomes a divided by b, then it is pushed. Then we have 4 and star. 4 and star goes on the top, is right. Then we pop 4 and put on the right, and then a divided b on the left. Now this is now another expression that will be pushed, a divided by b multiply by 4. This is pushed. And then we have AB again, A, B, and then we have plus. So this is plus, B goes on the right, A on the left. So this will become A divided B, multiply 4, then A plus B. Then we have minus. So this will be A divided B, multiply 4, minus A plus B. Okay, that is how it works. All right. So this is your answer. A divided B. Okay. A divided B multiply 4 minus A plus B. This is your answer. Evaluate the RPN expression where A is equal to 70. So let's say we have this stack which is empty. Then we put A in it. A is 17. Then we put B in it, which is 3. Then we have plus. So this will be 3 and 17. So 20 is pushed back. Then we have C. C is 48. Then we have D. D is 12. Then we have divide. So it means 48 divided by 12. So we have 24. 48 divided by 12 is basically 4. And then we have another divide. So this will be 20 divided by 4. So the answer that we will have is 5. Okay. So this will be, that is how we will answer it. Okay. Now, question number 5. This is about the graphs. Calculate the shortest distance between the base and each of the other towns in diagram using Dijkstra algorithm. Now you need to remember, I told you earlier that in Dijkstra algorithm, you find the shortest path from the base to every other node around. Whereas in A star algorithm, you basically find the shortest path from the base to one particular node. All right. So let us start. Okay. Now